One of the greatest human endeavors ever undertaken is the exploration of space. A big part of the surprise is the complexity. There are so many problems to solve and so many obstacles to overcome. But the most significant challenge is harnessing enough energy from rocket engines to propel a spacecraft in a zero-gravity environment. Thankfully, SpaceX has done this and they've done it well. They built a crazy Raptor bigger and better. But how does it work? And how could this change everything? Stay tuned as we dive into this and more in today's episode of Alpha Tech. The Raptor Vacuum engine is basically a space version of the Raptor engines that'll lift off from Earth underneath the Super Heavy booster. The variant of the Raptor engine will help the Starship travel through the vacuum of space by generating higher specific impulses inside the vacuum. It's like a steering wheel that's responsible for letting the spaceship in space move smoothly. Previously, the Starship was constructed with only 3 Raptor vacuum engines and 3 sea-level Raptors. However, with the latest revelation by Elon on social media in July, 3 more engines for the meaning of life, we will have a total of 6 Raptor vacuum engines powering SpaceX's spacecraft. The generated thrust will be formidable enough to execute the upward force required to lift the Starship while overcoming Earth's deep gravitational pull. Evidently, it stands apart from the smaller sea-level variants tested thus far. This iteration of the Raptor engines operates at an entirely different level in terms of both altitude and power. Have a look at this previously released photo of SpaceX. The Raptor vacuum is gargantuan. This enhanced size is primarily attributed to the significant expansion of the engine's nozzle. The widened nozzle of Raptor vac engines result in an area ratio of 200, necessitating a nozzle diameter of approximately 4 meters. This enlargement of the nozzle positively impacts operational efficiency within the vacuum of space. Due to its characteristics in a vacuum environment, the Raptor vacuum engine boasts an impressive thrust of 357 tons, with a specific impulse reaching a remarkable 380s. The specific impulse measurement surpasses that of many renowned rocket engines, including the vacuum version of the BE-4 engine with a specific impulse of 339s, the RD-180 with a specific impulse of 338s in a vacuum, and even the legendary RS-25 Space Shuttle engine with a specific impulse of 452s, but featuring 2 combustion chambers. But why do we compare specific impulses between vacuum engines? Specific impulse signifies how efficiently a rocket expels its propellant. It quantifies the rate of thrust generated by expelling propellant from the nozzle and is measured in seconds. A higher specific pulse implies a greater expulsion velocity of the propellant. This metric serves as a measure of engine quality, essentially reflecting how quickly the engine burns fuel to propel the rocket upwards. This is the most crucial key performance indicator of a rocket engine, as a faster and more efficient burn rate can accelerate the rocket to higher altitudes and velocities with less fuel consumption. Additionally, the specific impulse for vacuum engines always exceeds that of sea-level engines. In a vacuum, there's no atmosphere to provide pushback against the expelled gas, unlike at sea level, where the ambient atmosphere contributes to the thrust. For instance, SpaceX's current Falcon 9 launches employ the Merlin engine, which exhibits a specific impulse of 282s at sea level and approximately 311s in a vacuum environment. Therefore, it's only natural for the Raptor vacuum to possess greater power compared to its sea-level counterparts. Honestly, the future iterations of the Raptor vacuum engine are likely to be even more potent, possibly up to 400s, an impressive figure among all rocket engine lines. This is because SpaceX's engine development is progressing at an exceptional pace, exemplified by the Raptor 3 version, which boasts a staggering 17% increase in power compared to the current Raptor 2. We can't wait to see this. It's going to be awesome. Not only outperforming other rocket engines, but the Raptor vacuum engine is also a significant milestone in SpaceX's pursuit of advanced propulsion technology. This innovative vacuum engine variant builds on the foundation of its predecessors, incorporating distinctive features that cater to the demands of space travel. At the heart of the RapVac prototype is its ingenious regenerative cooling system. Unlike conventional cooling methods, Regenerative cooling involves circulating propellant, such as methane, through the walls of the engine's nozzle and combustion chamber. This process effectively absorbs the extreme heat generated during combustion, and it prevents overheating and structural damage. The regenerative cooling system enhances the engine's endurance and longevity, enabling it to withstand the rigorous conditions of space travel. The manufacturing process of RapVac's nozzle is equally remarkable. Crafting regeneratively cooled nozzles traditionally involve labor-intensive methods, such as assembling thousands of individual pipes. But the RapVac engine takes a novel approach. The nozzle is meticulously crafted from a copper sheet. This copper sheet is then enveloped by Inconel sheets, creating a sturdy and efficient channel wall. This manufacturing technique streamlines the production process and contributes to the engine's overall efficiency. In its pursuit of optimal performance and durability, the RapVac engine boasts additional reinforcements and protective elements. These components are strategically incorporated to enhance the engine's structural integrity and mitigate potential challenges. Notably, the interior of the engine features a white ceramic material, believed to reflect heat and safeguard the chamber wall against oxidation. Additionally, the design of vacuum engines is also given careful consideration to maximize their efficiency. The first factor that needs attention is the expansion ratio, which holds paramount importance in vacuum engines. This ratio, which represents the ratio of cross-sectional area of the engine's exhaust nodule at the throat of the area of the exit, plays a pivotal role in determining the engine's overall performance. A higher expansion ratio leads to enhanced efficiency by enabling the engine to extract more energy from the expanding exhaust gases as they propel the spacecraft forward. However, as engines venture into the realm of larger nozzles, a complex challenge arises in the flow separation phenomenon. Flow separation occurs when the pressure of the exhaust gases drops significantly, leading to the atmosphere exerting pressure back into the nozzle. This phenomenon can result in adverse effects on engine stability and thrust efficiency. Large nozzles are particularly susceptible to flow separation due to the decreased pressure of the exhaust gases in the vacuum of space. Here's a video that shows the main engine of the space shuttle running at full power. Before reaching the maximum thrust, you can see the exhaust flow spreading around the nozzle's tip, then gradually increasing, similar to accelerating a vehicle. Additionally, you can observe the nozzle oscillating more as this phenomenon becomes more pronounced in the rear. This phenomenon generates significant lateral forces, which, if sustained, could potentially damage the engine. Addressing the challenges posed by flow separation in large nozzles is vital for optimizing engine efficiency and stability. Engineers must carefully balance expansion ratios and nozzle sizes to mitigate the adverse effects of flow separation. Through meticulous design and advanced simulations, they strive to achieve a harmonious flow of exhaust gases that maximizes thrust while minimizing flow separation. Besides, the quest for an optimized RapVac engine also entails adjustments beyond the nozzle. The engine's powerhead, the heart of its intricate machinery, might need re-engineering to accommodate changes in flow rates and pressures. Furthermore, the intricate dance between propellant pumps and a dual turbo pump configuration demands meticulous synchronization to ensure optimal thrust production without compromising combustion efficiency. These changes, while challenging, could unlock the engine's full potential and set new benchmarks for space propulsion. In general, SpaceX's Raptor Vacuum is a mysterious beast in space. And as Elon keeps tweaking and upgrading those Raptors, the Raptor Vacuum will also benefit from his genius. But we haven't seen it in action yet. Starship 25 is still waiting for its date with a Raptor Vacuum. Maybe they'll hook up by the end of the summer if Elon keeps his word. And we can't wait to watch him soar into the sky and part ways gracefully. That's all for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section below. Your feedback's very important to us and helps us make better videos for you. Thank you so much for watching, and see you next time.